The law of conservation of mass states that in a chemical reaction, matter is neither created nor destroyed. This law was discovered by Antoine Lavoisier in 1785. This law can be exemplified by finding the mass of carbon monoxide. First, you add the mass of carbon with the mass of oxygen to get the mass of carbon monoxide. In this case, there are 2.445 grams of carbon and 3.275 grams of oxygen. By adding those up, the total mass of carbon monoxide comes to 5.72 grams. In this problem, no mass was created nor destroyed. Sig figs are present in this problem by number of decimal places.
Now we are simulating the law of definite proportions using a smoothie.
First, we'll take the masses of each of the ingredients. Peach yogurt, 4 banana slices, 3 strawberries, 3 apple slices.
The mass of all these ingredients weigh up to 208.5 grams. Time to make the smoothie.
Wait, we forgot the ice!
Oh no, that's gonna throw off the whole thing.
Our conservation of mass calculations would be all wrong.
Now we are adding 5 pieces of ice. 1, 2, 3, 4, 5. And that adds up to 70 grams. That makes our new total 278.5 grams.
Does that mean we can make the smoothie now?
Yeah! Time to blend.
After subtracting 181 grams for the mass of the cup, the total mass of the smoothie is 277 grams, only 1.5 grams off of the original ingredient amounts. After subtracting the excess yogurt and the little bits of smoothie left, as well as the melted ice, no ingredients were made or lost in this reaction.
The law of definite proportions states that any given compound always contains exactly the same proportion of elements by mass. This was discovered by Joseph Proust in the late 18th century. An example would be finding the mass percent of hydrogen and the mass percent of oxygen in H2O. First, divide the mass of each element by the total mass of H2O and multiply it by 100%. If this is done right, the sum of both of the mass percentages should equal 100%.
Even though the two smoothies have different masses, they contain the same ratio of ingredients.
This supports the law of definite proportions.
The law of multiple proportions. The definition is when two elements form a series of compounds, the ratios of the masses of the second element that combines with 1 gram of the first element can always be reduced to small whole numbers. This was discovered by John Dalton, who was an Englishman. In the problem below, to prove that CO and CO2 follow this law, you have to find the amount of oxygen that reacts with 1 gram of carbon. After doing this, you put them in a ratio of mass of oxygen reacting with 1 gram carbon. And when you divide these ratios, you should get a small whole number ratio, which means that this supports the law. Remember, this is not a sig fig problem.
For the law of multiple proportions, we will be looking at the ratios between strawberries and apples.
In the first smoothie, there is a ratio of 2.5 apples for every 1 strawberry.
In this smoothie, there is a ratio of half an apple to 1 strawberry.
By dividing the two amounts, you get a total ratio of 5:1. This is a small whole number which supports the law of multiple proportions.
Joseph Gay Luzak experimented with the ratio of the volumes of gases. He then discovered the law of combining volumes, which is sometimes considered a fundamental law. It states, when two gases are allowed to react, such that the gases are at the same temperature and pressure, the volumes of each gas consumed will be in the ratio of small integers. This law only applies to gases.
Thank you for watching.
All so good.